Okay, this is the last video with numbers 26 through 29. The fundamental period of 2 cosine 3x is, and we talked about this on a couple of occasions, it's 2 pi divided by whatever's in there. So 2 pi divided by 3, which is a. I'll just take a quick second or two to explain what fundamental means. Remember, something that's periodic, periodic means repeating. And the period is that interval during which time it repeats. The fundamental period means the shortest amount of time in which it repeats. Because you could say, if you had like a cosine function, for example, you could say, look, from here to here, that's a period of the cosine function, right? Because you could just snip that and keep pasting it, and then you'd get the whole thing, right? And that's true in a sense, and that would be like a period of 4 pi, right? If this were the regular cosine curve. But you could actually describe it as having less than that, right? It would be like saying, like, what's the period of the rotation of the Earth on its own axis? Think about that for a second. The period of rotation of the Earth on its own axis is 24 hours. Now you could say, well, its period is 72 hours. And that's true in a way, because after 72 hours go by, the Earth would be in the same spot as it was 72 hours earlier, right? It'd be at the same place in its rotation. But it will have made 3 complete revolutions. So we say the fundamental period is that smallest amount of time, or smallest amount of x in this case, that describe one full cycle of the function or rotation or whatever. So that's what that fundamental means. Number 27, the graph of y equals f of x is shown in the figure above. So here's our function. Looks like it has zeros at -4, -1, and 1. Which of the following could be the graph of y equals f of the absolute value of x? Okay, now, we've talked about this before, and we did talk about what happens when you put absolute values around the outside of the function, right? Around the outside of the function. That flips everything that was down up. So if you thought that it was this, you were right for a different question. This is a graph of y equals the absolute value of f of x. And that is very different from this, right? Now, this is not the correct answer. What this does is it takes, if you go trying to plug in negative x values into this, what happens is before they get plugged into the function, they get made positive. So everything, all of the negative values that you try to plug in get made positive, and you just get a copy of the graph, what it would have looked like for those positive numbers. So this part of the graph gets wiped out, and as you try to plug negative numbers in, the function just ends up doing this. For example, when you plug in, let's say, that's 3 there. When you try to plug in -3, right, when you go over here and say, I'm finding the value of the function at -3, you try to plug -3 in here, and it makes it positive. So in fact, you get the same value as you would have got for f of 3. So it's kind of like, doing this is kind of like a function evener, if you want. It like turns everything into an even function. It takes all the negative numbers you would have got, maybe some unique, interesting part of the function over here. It obliterates that and just recopies what happened over here, reflects it over that. So that's that looks like C. If you picked one of the other answers, I would encourage you to reflect on where the error in your reasoning was, and make sure that you understand how we got to the correct answer of C. All right. Last page. What are all horizontal asymptotes of the graph of y equals 5 plus 2 to the x and 1 minus 2 to the x? Well, all of them makes me think, I don't know about you, that we might want to consider what happens as we go to infinity and what happens as we go to negative infinity. I mean, how many horizontal asymptotes can you have? I don't think you can have more than two, right? You could have one as you go to positive infinity, one as you go to negative infinity, but you can't have more than that. Let's consider these. So 5 plus 2 to the x over 1 minus 2 to the x. As x approaches infinity, these blow up to an even larger version of infinity, and the 5 and the 1 fade off into obscurity. So 2 to the x over minus 2 to the x would be negative 1. And then here, so I think that eliminates those right off the bat. As we go to negative infinity, well, what does it mean to raise something to a negative power? As we raise 2 to negative powers, that flips this over, right? So that's like 1 over 2 to the infinity. And so 1 over 2 to the infinity, that's something that's getting smaller and smaller and smaller. It's 1 over very, very, very large number. Now that's going to go to 0. This is going to go to 0. So instead of these fading off like they did here, now these are going to 0. So 5 over 1, that's 5, and so we have 2 horizontal asymptotes. Again, you were not supposed to use your calculator for any of these, so if you got that by graphing, I think you need to reconsider and make sure that you are able to reason through that without the aid of the calculator. Number 29, let f be a function that is continuous on the closed interval from 2 to 4, and f of 2 equals 10, and f of 4 equals 20. Let me just make a quick sketch of that. We'll say here's 10, 20, here's 2 and 4. So we're going from 210 to 420. And it's continuous, so that means no whole skips or vertical asymptotes as we go from this point to this. Which of the following is guaranteed by the intermediate value theorem? Intermediate value theorem says that every single y value between 10 and 20 has to get hit. We can't skip over any of them. So let's see, f of x equals 13 has at least one solution in the open interval from 2 to 4. That is true, right? That's like saying it's got to cross the line at 13. So I think that's the answer. Let's just check out the other one. Does f of 3 have to equal 15? No, well, it's got to go from here to here, but it doesn't necessarily have to be equal to 15 exactly halfway through. Although my little graph looks like it might. F attains a maximum. Well, it doesn't. It's going from here to here, so it could just be a straight line, in which case it would not have a maximum on the open interval, right? So that's not necessarily true. And then F, oops, this should have been eliminated because you don't know what that means, that little prime there. That means the slope of the function is greater than 0 for all x. That's like saying it's only increasing, but of course it could do that, right? So that's not right either, and I humbly apologize for leaving that in there. Hope that didn't confuse you. But maybe you convinced yourself that A was the right answer, in which case you were right.